Hi, my name is Marco SCHIRONE and I work at Chalmers University of Technology in Sweden, and I'm also a PhD student at the University of Borås. And I'm here to present my paper titled STEM Information Literacy, a Bibliometric Mapping. More than 15 years ago, the American Library Association published the Information Literacy Standards for Science and Engineering Technology. Since then, diversity in terminology has characterized the epistemic landscapes of information literacy research focused on science and technology fields. And we have example of this just by looking at Aris, who has used the expression STEM information literacy with the acronym STEM, meaning science, technology, engineering, mathematics. Quite differently, other authors have coupled information literacy with specific science and technology disciplines, as in the case of engineering information literacy in the recent systematic literature review by Phillips and her colleagues, or chemical information literacy in the article by Bowden and Robbins. Recent studies have employed bibliometric methods to analyze the scholarly output of information literacy research. In the existing literature, however, an overarching mapping of the field from the specific disciplinary perspective of STEM is still missing. So that was my research problem. SIL, information literacy, is a field of research, but also a field of practice. The aim of my paper is a twofold one: to gain insight on the research in the field, but also to assist the practitioners in identifying relevant publication channels and trends. The paper focuses on three aspects of the literature: the publication output, the authors, and the topic. And those aspects correspond to the research questions shown on the next slide. The first research question is: which are the main publication channels and documents in the field? The second one: who are its authors? And the last one: which are the major topics?
Moving on to data sources and methods, we have to say that there is no agreement on how to define STEM or STEM disciplines. However, in spite of this lack of agreement, the term STEM, which emerges from a policy context and an American policy context, and more specifically the context of educational policies, the term STEM offers the opportunity to operationalize the definition of science and technology field and to work with the tools and methods of bibliometrics to further analyze what basically STEM information literacy is in terms of a research field. And we have also to remember that STEM has been used outside the US, even if was conceived originally from in the context of American educational policies. In particular, the classification of instructional programs, CIP codes of the US Department of Education, allow us to establish in operationalized terms which disciplinary fields ought to be considered as STEM and should be included in a bibliometric analysis of this type. And those fields are those included in the STEM policies more generally. The period 1974-2020 was chosen because 74 is the year of the Zwicky report and 2020 was the year, the last completed year at the time of the data analysis and the writing of my paper. Using a query in the review by Phillips and her colleagues, I extracted from Web of Science core collection all documents relevant for the information literacy field, so more than 8,600 English language documents were so identified. Using the CIP codes, more than 40 million documents were retrieved as relevant for STEM, and of course there were intermediate steps in the retrieval of documents from Web of Science. Bibliographic information regarding those documents retrieved from Web of Science was imported in R, and in particular I've used the R packaged Bibliometrics to perform bibliometric analysis in the R environment. And using data cleaning algorithms in R, I could gather a final set of documents consisting of 6,621 documents, which also amount to almost 15,000 references in the reference lists and 15,000 individual authors, and as well 12,000 author keywords. The method chosen to answer the research questions were bibliographic coupling, the historical direct citation network, and the thematic mapping. So those three methods were at different stages employed to analyze the field of STEM information literacy. Looking at the findings, we can see here a table with the top sources according to the number of documents in the dataset. And at the very top, we found the Journal of Academic Librarianship and the College and Research Libraries, followed by Reference Services Review, the Journal of Documentation, Evidence-Based Library Information Practice. And further down, we also notice well-known LIS journals such as Information Research and more specialized journals such as the Journal of Chemical Education. Combining the R package Bibliometrics with the software VOS Viewer, I could obtain a density map of the journals based on the relation of bibliographic coupling, which is a relation according to which document A and document B include a document C in the both of them include a third document C in the reference list. And based on this relation between documents, we have here the distance between journals, or the closeness between journals, and also based on the number of links in the network, we see also the core journals defined by a darker color in the network. Based on bibliographic coupling, I've also explored the relations between documents which are identified here by year and the first author. In the additional files of the proceedings, you will find also the complete data set of my paper, and you'll be able to find out which documents are the oldest one in this heat map or density map. Just a few words about this density map. We see very often Maria Pinto as first author of impactful papers, and also other well-known names in information literacy, such as Alison Hicks, for instance, or Jeff Walton, and even quite very central in the map also more recent work by Elena Hollis. This network is based instead on direct citation. So document A citing document B. There is a timeline from left to right, and we see here as a milestone the paper by Leckie, and also we have a quite large cluster of documents characterized by the red color. In this cluster we found works by Bill Johnston, David Bowden, and more recently also the paper on the assessment of information literacy by Serap Kurbanoglu, and even here, more recently, work by Maria Pinto. Here we can see the most productive authors, and at the very top we found Maria Pinto. There is a timeline, and we can see that there is an increase of research on STEM information literacy after 2010, and also we see here other authors that we have not encountered in the network based on bibliographic coupling, such as Michael Forsmeyer, an author that has published extensively in engineering information literacy. After having answered the first research question on publication channels and core documents, and the second one on authors, the last research question to be answered was tackled by using thematic mapping, which is a method developed by Kobo and colleagues, a clustering method based on co-occurrence of terms in the titles, in the abstracts, and from the author keywords of the papers. We found here clusters of topics. Some of the clusters are not surprising. We have teaching, library instructions, student literacy, higher education, learning approach, but we find also healthcare, lessons learned, review, online search. Most of the terms are found in one particular section, the one that is dedicated to the intellectual basis of a field, the basic themes of a field, upon which the field lies and from which the field is developed. So we can say that having most of the topics in this session will indicate a degree of cohesion in STEM information literacy. Even if healthcare is found in the section dedicated to motor teams, so teams that further develop a field, teams that are typical for the research front. To summarize, we can say that among the most significant findings are the following. The core publication channels are library information science journals, but at the same time, we have also found a certain degree of specialization towards specific STEM context, such as the health sciences, engineering, and to a minor extent, chemical education. In the paper, I attempt to interpret the findings in light of Richard Whitley's sociology of science, an organizational approach to the study of scholarly fields, and Anne-Marie Lloyd's sociocultural perspective in information literacy. Whitley uses the concept of mutual dependency and task uncertainty to study and classify scholarly fields. Mutual dependency is the dependency of researchers upon each other in deciding who the authorities are, the core journals, and so on. And fields where there is high mutual dependency are fields where we see this agreement among scholars. If we think about mutual dependency, we can say that information literacy appears to have a quite high degree of mutual dependency. But the other category that Whitley uses is task uncertainty. Uncertainty related to how to go about research problems, the variation in ways and methods to further develop the field, and the niches as well that can be created because, for instance, there are different methodologies and different approaches, quantitative, qualitative, and so on. So we can say that we have also found a certain degree of task uncertainty which derives from the landscapes of STEM disciplines. What I mean by that, we have task uncertainty that is rooted in LIS and information literacy. Uncertainty related, for instance, to the concept of information or how to develop the library instructions and those issues. At the same time, the plurality of local contexts, such as engineering, health sciences, chemical education, is a variable that has, in my view, task uncertainty. This can also be interpreted through the sociocultural perspective of Anne-Marie Lloyd. We can say that there is a centripetal force that organizes the field of STEM information literacy around information literacy research and LIS research, but at the same time we have also the effects of a centrifuge force that moves from LIS to the STEM disciplines. Those various contexts can be interpreted not only in terms of task uncertainty, but also as socio-cultural context, as the plurality of socio-cultural contexts, which has been, for instance, also recently investigated with colleagues, also in previous research which I have conducted regarding workplace settings and information literacy. So future research could further investigate the tension between LIS and the STEM perspectives and the context of STEM disciplines. Thank you so much for listening, and I look forward to your comments and questions. And of course, I have also to say thank you to my supervisors, Associate Professor Bjorn Hammerfeld and Associate Professor Elena Franke, for the help given, and also at Chalmers, Dr. Tahir De Daridad, and my manager, Christina Johansson. So I look forward to your comments and questions.